Hi, Assalamualaikum and hi everyone. My name is NURA BAQIZAH binti BASRI. My metric number is B122310295. In DSP, we use windowing to shape how our filter behave. Let's look at two common type of windowing filter. First, rectangular window, which is easy but can use unwanted leakage. Second, hemi window, which is reduced leakage but it's less sharp in frequency resolution. Objective in our topic on the discussion is, first, to demonstrate the characteristic and the difference between the rectangular window filter and the hemming window filter. Second, to design the rectangular window filter and the hemming window filter. And last, to demonstrate the application of each filter. Introduction of windowing in filter design. When we design filter, we use windowing to shape how they behave. Think of windowing as a way to control the filter response, both in time and frequency. It's an important technique, especially in FIR filter, which is finite impulse response filter, which are widely used in signal processing. First, rectangular window filter, which is, while it's simple and easy to use, it has some drawback like spectral leakage and ringing effect. Second, hemming window filter, which, compared to the rectangular window, the hemming window works better at reducing side lobes and giving a cleaner results.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad FIRDAUS bin Muhammad RAWI. My number metric B122310220.
Okay, first, rectangular window filter. The rectangular window is mathematically defined as show where n is the window length. The characteristic of the rectangular window filter is that it is a simple window function. The main lobe is narrow, which shows its better frequency resolution and made it easier to differentiate between closed space frequency. This side lobe have low attenuation, which means that it is quite high. This will lead to spectral leakage and make it difficult to identify the true frequency content of the signal. There is also the ringing effect that is caused by the abrupt transition at the edge of the rectangular window.
Here are the steps to design rectangular window filter. Step 1. Determine the types of filter such as low pass filter. Step 2. Determine the design parameters such as the sampling frequency, the cut-off frequency and the filter length. Step 3. Obtain the ideal impulse response. Step 4. Multiply the ideal impulse response with the rectangular window function. Step 5. Compute the frequency response and analyze it. Demonstration of rectangular window filter using MATLAB. Output MATLAB. The impulse response of FIR filter with rectangular window. The central peak represents the main lobe of the filter and the ripples in the side lobes will lead to spectral leaks which can destroy the true frequency content of the signal being filtered. The frequency response of FIR filter with rectangular window. It will show a passband region where the gain is relatively high and a stopband region where the gain is significantly attenuated. Application of rectangular window filter. The rectangular window filter is suitable for applications that are less complex and resource limited. It can be used to design a filter that will remove noise from an audio signal. Thank you.
Hello, Assalamualaikum. My name is Muhammad HAYKAL bin MURIZAN. My metric number is B122310227. Okay, I will continue from my friend explanation. Now demonstration on MATLAB. Okay, this is the output for the MATLAB for the rectangular window. The filtered signal using rectangular window low pass filter. The filtered signal will have the high frequency noise attenuated, but it is not as smooth due to the spectral leakage. The Hamming window is defined by the following equation, where n is the total number of the filter coefficient. Next, the Hamming window is a function that has a moderate side loop suppression. This reduction in side loop lead to lower spectral leakage, which improve the accuracy of the frequency analysis. The main loop of the Hamming window is slightly wider than rectangular window, which provide a balance between frequency resolution and its side loop suppression. This characteristic allow it to be widely used in finite impulse response, FIR, filter design and spectral analysis. Okay, now step to design the Hamming window filter. Okay, number one is to determine the type of filter such as low pass filter. Determine the design parameters such as the sampling frequency, the cut-off frequency and the filter length. Step number 3 is to obtain the ideal impulse response, and next multiply the ideal impulse response with the Hamming window function, and lastly compute the frequency response and analyze it. Next is a demonstration of Hamming window filter using MATLAB. Okay, that's all from me. My friend will continue.
Hello, my name is Loong and my matrix number is B122310142, and this is the output MATLAB for frequency response of Hamming window FIR filter. The frequency response of the filter shows that reduction in the ripples in the passband and stop band of the filter's frequency response compared to a rectangular window. The application of Hamming window filter. The Hamming window filter is suitable for audio signal processing such as noise reduction. Here is a demonstration on MATLAB. Output MATLAB. Filter signal using Hamming window filter. The noise is significantly reduced while retaining the sinusoidal component by showing a clear reduction in noise. This demonstrates the utility of the filter in real-world applications like audio and speech processing. The downside is that the wider main lobe slightly reduces the ability to distinguish closely spaced frequencies. In conclusion, the Hamming window is more versatile tool compared to a rectangular window in FIR filter design because it balances side lobe suppression and frequency resolution. Through MATLAB, we demonstrated its effectiveness in designing a low-pass filter and its application in noise reduction, highlighting its importance in digital signal processing tasks. Thank you.